Okay, I anticipate several questions here in 27, 26, 27, 28. But the first thing I want to do is look at 29 and see if we can't get this to make sense, and then go back and look at those and see how they're connected, how they're related. Find all values of theta in radians if theta is in the interval from 0 to 2 pi. So first of all, this little notation about being 0 to 2 pi is just so that we understand we're finding all angles in one revolution and not going around and around and around and around, wasting time. So the first thing, it's kind of like in class then the other day that we said there will be two places where cosine is negative. There will be a place in the student's location, and there will be a place in the take location there. All students take calculus. Those two places, cosine's negative. Once you know that, you probably want to know that when it says the cosine of theta is the square root of 3 over 2, that the x, that's a recognizable number, isn't it? And the x, the square root of 3 over 2, is the x. Y is its partner 1/2. Based off of that, we have an angle, hopefully, that triggers in our minds for the square root of 3 over 2 as pi over 6. That's the reference angle, and that is the angle inside each of these triangles we drew here. What we want to know is the answer from 0 to that radius, so it would be 5 pi over 6 in this case, because we fell short of 1 pi, and it would be 1 pi and a 1/6 pi more, so 6/6 and another 1/6 is 7/6 of pi for this one. Okay, hopefully this will help us lead into the ones that came before actually, so let's go look at those now. Okay, back to number 27 here. This number 27 is probably one of the most tricky problems we see because it has secant given to us, and we do not want to be able to, or don't have the ability to deal with secant directly. So the first thing we're going to do is write this statement about secant in terms of cosine. So we'll say cosine is equal to 1 over 8.8481777. We are 100% allowed to flip sides, and if we flip secant, that would be called cosine. If we flip cosine, that would be called secant, and that is good. We can't flip angles, so if you ever have like pi over 3, we can't call that 3 over pi because we never ever flip angles, but we can flip sides. And doing so then allows us to use cosine inverse to get back to having the angle. So we have one inverse cosine of 1 over 8.8481777, and place that in your calculator, being in which mode, of course, we want that angle in terms of pi, or not in terms of pi, but in radians. So let's set our calculator to radian mode. When I find that out here, the reference angle I get for my calculator is 1.457 and a whole bunch more. So let's figure out where we're going to put that reference angle. We are in which two quadrants if the secant is positive? That is also if the cosine is positive. Cosine is positive in 1, and cosine is positive in 4. All students take calculus. So obviously the reference angle, if we are in quadrant 1, the reference angle is exactly one of the answers. In the second one, the reference angle is only the triangle part, the little triangle angle in there between the x-axis and r. So if we're coming from 0 around to try and figure out what that actually is, it would be 2 pi minus that reference. Okay? So I'm going to say 2 pi minus, since that's the answer, last answer on my calculator, I'll go second answer, and it gives me 4.8256, so on and so forth. So which answer is that? Well, we want the one with 1.457 and the one with 4.8. So that looks to be option B. Now be careful of one thing here on problem 28. You know, it's a little more straightforward. It says sine is this long decimal. So obviously we have inverse sine, but be careful here because see how it wants the answer? it wants the answer to be in degrees, and therefore you need to have your calculator in degree mode before you go inversing sine. Okay? Let me know if you have any questions. Okay, so I'm back here on 26 looking at what it's asking. It says find all values of theta if theta is in the indicated interval and has the given function value. Give approximations to as many decimal places as your calculator displays. So what we have going on here is we know the tangent is this equal to this 7.604798721. We want to find theta, and according to this, we want to find it in radians, because we want to stay between 0 and 2 pi. So since that's radians, we'll find this in radians. So the first thing you want to do is set your mode to radians. Once you're in radian mode, then we know to get from having the answer for tangent to having the answer for the angle requires inverse tangent. So inverse tangent 7.64798721, and if you do that on your calculator, I get 1.44, and I'll say 1, but it's 0.7. And what we realize here then is that that is the reference angle. Well, what we need to know is where do we put that reference angle? Well, according to this up here, tangent was positive 7.64. So tangent is positive if you are in the first quadrant and third quadrant. Well, if I'm in the first quadrant, the reference angle we've learned kind of in class is exactly one of the answers. So yeah, go looking for one of the answers to have 1.441 blah blah blah. Okay. The other one, if we look, that's the reference angle here in the triangle, but we want to come from 0 all the way to there. So if you notice in terms of radians, we made it to pi and then some more. So the other answer is pi plus 1.441 blah blah blah. So if you do that, pi plus answer while it's on your calculator, you get 4.58, so on and so forth. So now let's find those answers. One of them was 1.44 and the other one was 4.58. Looks like B.